Good morning, sir. This is Zakir Hussain S. of Computer Science and Engineering Department from first year. Today, my topic is to discuss about diffusion currents. Moving to the next slide. Here is the outline of the entire presentation. Slide 3. Introduction to diffusion currents. Basic concepts of charge carriers. The diffusion process. Fixed law of diffusion. Mathematical representation. Diffusion current in semiconductors. Role of temperature. Diffusion current in electrolytes. Drift versus diffusion current, total current in semiconductors, applications of diffusion current, limitations and challenges, and conclusion. Here, introduction to diffusion currents. Diffusion current refers to the flow of charge carriers due to gradient. It plays a vital role in semiconductor physics and electrochemistry. Understanding diffusion current is essential for applications in devices, diodes, and transistors. Here, left side, higher concentration region, diffusion electrons, lower concentration is the right side of the figure. Non-uniform concentration of electrons move towards uniform concentration of electrons. Basic concepts of charge carriers. Charge carriers in solid include electrons and holes in semiconductors. In electrolytes, ions are the primary charges and charge carriers responsible for current flow. The movement of the carriers driven by concentration. Here we can see p doping and p-type n-type semiconductors. The diffusion process. Diffusion is the process where particles speed from areas of high concentration to low concentration. This movement continues until the concentration is uniform medium. The rate of diffusion is influenced by temperature, medium, and concentration difference. Here we can see diffusion versus osmosis. Diffusion, solute move from high to low concentration. Osmosis, solvent move from low concentration to high concentration. Fixed law of diffusion. Fixed law states that the flux of particles is proportional to the concentration gradient. Fixed seconds law describes how causes the concentration change time. Both laws are fundamental to understanding diffusion current. Here assume that the flux is proportional to the gradient of mu of A. Q of A equal to minus D into C by RT into D of mu A by dx. Mathematical representation. The diffusion current density J can be mathematically expressed as J equals to small q of T into dou n by dou x. In this equation, Q represents the charge of carriers, D is the diffusion coefficient, and dou n by dou x is the concentration gradient. This relationship illustrates how diffusion current is quantitatively analyzed. Diffusion current in semiconductors. In semiconductors, both holes and contribute current. Movement of these carriers is critical in determining semiconductor behavior. Diffusion current is especially important in PM junctions operations. Role of temperature. The temperature affects the mobility of charge carrier diffusion coefficient. Higher temperature generally increase the rate of temperature. This temperature dependence is crucial for the operation of electronic devices. Diffusion current in electrolytes. In electrolytic solutions, ions diffuse to maintain charge neutrally. The diffusion of ions creates a current known as ionic condition. This process is fundamental in batteries and electrochemical cells. Drift versus diffusion current. Drift current is caused by an electric field, while diffusion current carries from concentration gradients. Both currents can occur simultaneously in a combine. Understanding the difference is crucial for analyzing electronic devices. Total current in semiconductors. The total current in semiconductor is the sum of drift and diffusion currents. That's why we should know drift current. This combined effect determines the overall behavior of devices like transistors. Proper analysis of both currents is essential for device design. Applications of diffusion current. Diffusion current is a key in operation of photovoltaic cells and photodetectors. It is also integral to the functioning sensors and ion selective electrodes. Understanding diffusion currents can lead to advancements in electronic and electrochemical technologies. And we can see the graph, and we can see X illuminance and Y axis photocurrent. At VR equals to 0 volts, VR equals to 1, VR equals to 5. Limitations and challenges. The analysis of diffusion current can be complex due to non-ideal behaviors. Factors like recombination of charge carriers can complicate the current flow. Understanding these limitations is important for accurate modeling and prediction. Conclusion. Diffusion current is a fundamental concept in physics and engineering. It plays a crucial role in the behavior of electronic devices and electrochemical systems. A comprehensive understanding of diffusion current can enhance technology's innovation. Thank you, sir. Presentation by Zakir Hussein S. of Computer Science and Engineering Department from first. Thank you.